So the last couple of sections in this chapter just kind of look at first the cold air masses and then the warm air masses, just a little bit more, or kind of rehashing in some cases, rehashing important information about these air masses. Most of this is already in that table from your textbook, Chapter 8, Table 1. So continental polar air masses, remember they have just one source region basically for North America. And we said that they tend to be stable air masses, which means that they don't tend to want to rise vertically. And because of that, actually, if a region is under the influence of a continental polar air mass, sometimes the pollution, for instance, that a city generates will be stagnant, and it can actually kind of aggravate air pollution. So they're generally dry, continental, and they're stable. They don't want to ascend. So usually we have nice no clouds associated with continental polar air masses, and nice bright sunny days, even though they might be kind of chilly. Summer characteristics, generally no temperature inversion. Remember, temperature inversion in the troposphere means as you're ascending, temperatures get warmer instead of colder. So there is a slight difference between summer characteristics and winter characteristics. Notice that continental polar air masses, they don't move too far south. So continental polar air masses actually are responsible for something known as lake effect snow, and I bet you've heard meteorologists talk about lake effect snow. Of course, the lakes in lake effect snow would be the Great Lakes. And so this is the way it works, basically. In the wintertime, those large bodies of water, the Great Lakes, actually will tend to retain their heat. Okay. Then, and I have a picture showing you this lake effect snow on the next slide. It's kind of neat. Then basically that we're going to see that air is blown from the north. I'm not sure about north or northeast. Seems like it should be north-northwest, but just not sure about that. Anyway, these continental polar air masses, dry, cold air masses, are blown over the lakes. And what you're going to see on the next slide is basically that since the lakes are warm, I'm going to redrawing basically that picture on the next slide. Since the lakes are warm, basically what happens then is that it has a lot of little H2O molecules are vaporized. So basically we have moist air right here, and as that continental polar air mass moves into that moist region, then it can pick up moisture, and it's already cold, P for polar, and so then basically it turns into maritime polar air, and then it hits the land again. This is land, this is land. Okay, and as it hits the land, one of the things we talked about is because of friction, the air kind of piles up here, and it makes a high pressure, and that is like a lifting mechanism. And so then what you can get is these cold, moist air gets lifted, and voila, that's my cloud right there. You have cloud formation, and to the point of, and they're moist to the point of, oops, let me make these, snow can dump on the other side. So that's basically what you're going to see on the next slide. Continental polar air masses move over warm Great Lakes and become saturated, and as they go on shore on the other side, they lift and we get lots of snow. Okay. So here you go. Notice that it's nice and cold over here, and up here we've had some sort of source region that created our continental polar air. And this isn't necessarily going from, we could think of this as north to south, some sort of kind of northerly wind. And so we've talked about the fact that large bodies of water, such as the Great Lakes are, will retain their heat. Notice the warm lake water here, And so what that does is provide extra, these are my little water vapor molecules here. Okay, and so then that continental polar air mass that moves over can become modified. No longer is it continental, but basically it's picking up kind of maritime characteristics. It's still relatively cold. And then when it reaches the land over here, which could still be negative 18 degrees Celsius, I'm not sure, but still what will happen is friction will make a relatively high pressure here, and it will ascend. And so down here, what you're seeing actually does look like a westerly wind, okay, because I don't know if you can see this arrow here, okay, blowing across. I think that would be Lake Michigan, I'm not sure. But Buffalo, New York right here is getting hit. I don't know if you can see it, getting hit with this is a satellite image of cloud cover. And lots of clouds there. Buffalo must be getting hit with lake effect snow. So the way you read this map is the colors indicate the snowfall. So I'm not sure what our snowfall necessarily is here in Iowa, but in terms of inches of snow in a given year, notice those dark blue regions are getting greater than 130 inches of snow for the year. The lighter blue, 100 to 130, and then 60 to 100. So that's lake effect snow. And notice that it is mostly on the downwind side of a kind of a westerly wind, northwesterly wind. So another cold air mass would be those Arctic air masses, continental Arctic air masses. They're colder than continental polar, but they're also dry. Both continental polar and continental Arctic air masses are dry. We call the boundary between these two cold, dry air masses, one very cold, I guess I should say. The boundary between the very cold, dry air mass and the cold, dry air mass is called the Arctic front. And this is showing us the Arctic front, or an example of a clash between these two air masses. Continental Arctic, continental polar, and then there is an Arctic front. This front is not as steep as something that we talked about in the previous chapter. Remember when we talked about the 3 cells in both hemispheres? We talked about a polar front that was between the polar cell and the feral cell. Okay, so I don't know if you can kind of see this. This actually is a figure that's not in your textbook. But right here, this is the polar front. It's between the polar cell and the feral cell. And notice that the polar front is much deeper. And an Arctic front actually can, even though they're both dry air masses, continental Arctic, continental polar, we can sometimes get some sort of precipitation because of that abrupt change in temperatures there. And this Arctic front can, like you see, extend as far as the U.S. border sometimes, U.S. border with Canada. So the last cold air mass to talk about is the maritime polar air masses. So maritime polar air masses, we said, there's 2 source regions, one on either side of North America in the Pacific and the Atlantic Ocean. They don't generally tend to be as cold as their counterpart continental polar air masses. They're dry, cold air masses. And their source region is a large body of water. The ones on our west coast that form over the North Pacific, they affect California. The ones that form on our east coast, or the source region on our east coast in the Atlantic, they affect the Northeast. If you've ever heard the weathermen talking about the nor'easters or the northeasters, it's the same thing. Actually, what we're going to talk about in the next chapter is something called a mid-latitude cyclone. It's very cool. Just to kind of introduce you to a mid-latitude cyclone. What you're going to see is on the weather map, it looks like this. Where we've talked about this. This is a cyclone, isn't it? With tight isobars. And one of the things about cyclones is oftentimes they tend to have both, let's see, if I think I might have they have, I'm trying to draw kind of a cold front here and a warm front. Okay, and we can tell the cold front from the warm front in that, oh sorry, this got a little messy here. We can tell the warm front from the cold front in that the warm front I'm drawing here has semicircles, and warm air is going this way. The cold front has triangles, and cold air is coming this way. My point is that when we, and this is called a mid-latitude cyclone. My point is that this is a good source of bringing, picture this on our northeast United States, and we have a source region for maritime polar air, and it can bring that maritime polar air in. And so this is an example of a what we call a northeaster weather system. Okay, so last slide talking about cold air masses. Then we get to talk about warm air masses. So this is showing you air mass modification. For example, we talked about that, where an air mass actually, after it's taken on characteristics of its source region, once it gets to moving, it kind of changes its characteristics. It becomes modified depending upon what it moves over. So for instance, we're leaving, this is North America over here. I don't know if you can kind of see this, NA for North America over here. And a source region in a different part of the world for continental polar air would be air mass over here. Notice that it looks like it's under the influence maybe of the mid-latitude westerlies, or maybe just Rossby waves in general, and it's heading eastward, marching eastward, kind of southeast, isn't it? And notice as it goes from here to here, it is still it's still chilly, but instead of being cold, it's cool, and it is beginning to pick up a little bit of moisture. So instead of being strictly continental, it's got some moisture to it. And then notice that the same air mass now, it dwells over the Pacific here, and it becomes moist. So basically, we have modified a continental polar air mass into a maritime polar air mass.